Hello! So, today we are going to be looking at 7.5c, which means it says solve mathematical and real-world problems involving similar shapes and scale drawings. Okay, well, we've already talked about similar shapes, but we haven't really talked about scale drawings. So that's what we're going to be looking at. I guess we're going to be using similar shapes in scale drawings. Anyway, a scale drawing, what is a scale drawing? Is a proportional two-dimensional drawing of an object. Scale drawing can represent objects that are smaller or larger than the actual object. Okay, so they're kind of like models, or for houses they have blueprints. It's kind of like that too. A scale, what's a scale? Well, obviously it's not something you weigh yourself on. It's a ratio between two sets of measurements. A ratio, remember a ratio can look like a fraction or a proportion. Alright, so here's our example and our steps on how to do the example. So the example says the art class is planning to paint a mural on the outside wall. The figure is a scale drawing of the wall. What's the area of the actual wall? Well, right now I know that this is my example that they're talking about. This is the picture that they want to go on the wall. Well, obviously this is not the size that they're going to paint on the wall, because down here we have our little key, because you know in history you have a key, right? Well, our key says 2 inches is really 3 feet. Okay, well, I could set up a proportion, but what is the question actually asking me? The question isn't just asking me set up a proportion, right? It wants to know what's the area of the actual wall. Well, I know the area of a wall. I see that this is a rectangle. I have to think back and think about what my formula for a rectangle is. And if you can't remember, you can look at your formula chart. Your star chart will tell you that the area is length times width. But I don't want to know the area of the scale drawing right here, so I can't do 28 by 11 because that doesn't make sense. That'll give me the area of this. I want to know of the whole wall. So my first step is set up a WGU for your length and then determine the amount of feet. So WGU. Now, normally when we're talking about similar figures, you would have been right if you put short side over long side. But right now we're not going to do that. Right now we're talking inches to feet. We're kind of going back to conversions a little bit. What do you for sure know? What did they give you inches and feet? I see inches and inches here, but I see inches and feet right here. Remember, this was kind of like your conversion factor. What you found on your formula chart went in your G. So we have 2 inches is 3 feet. So your G is going to be your key info. What I mean by key info is, remember we talked about this having like a scale or a map on a map. Okay? Now, I know I'm going to have to figure out how long the wall is in feet and then how tall the wall is in feet. But for right now I'm just dealing with length. And length is horizontal. So I have 28 inches. So am I going to put 28 inches in the inches column or the feet column? Well, it says determine the amount of feet, so I don't want to know the feet, I know the inches. Okay, so we're solving for feet, that's why we put our variable here. Now you can take this out and make a proportion out of it. Cross multiply, 2x is equal to, I want you to pause and do what 28 times 3 is. I'm going to do it over here. I got 84. Okay, divide by your coefficient to isolate your variable. X is going to be equal to, you should have got 42 feet. Okay, so our length is 42 feet. But we only know this now. We can't find the area, 42. We can't find the area without the width as well. So we need to find the width. Alright, so set up a WGU for your height now, or width, and determine the amount of feet. Same thing, WGU. Still doing scale figures, or scale drawings, so we're still going to use our quote-unquote key. Sorry, I did inches on top last time. Would it have mattered if I did feet on top? No, I just would have had to make sure 3 goes with feet and 2 goes with inches. Alright, see how much you can fill in of your WGU. Your G should have been still 2 over 3 if you did inches over feet. And then you should have, instead of having 28 this time, you should have had 11. Okay, and X, we're still trying to figure out how tall it is in feet, so that's why X is our variable. Pull it out and make a proportion. Cross multiply, cross multiply. I know 11 times 3 is 33, is equal to 2 times X is 2X. Divide by your coefficient to isolate your variable. See if you can figure out what X is equal to. If you would have worked it out, I didn't work it out yet, so I'm working it out right now. Right? Nope, I lied. 16.5 feet. Alright, 16.5. So I know that my width is 16.5. So now step 3 says, now that we know our length and now that we know our width, we need to combine them together to find the area. Well, we talked about area being length times width. So you figure out what the area is. In case you get stuck, you can watch, but I know some of you jump ahead sometimes. 2 times 6 is 12, plus 1 is 13. 2 times 1 is 2, plus 1 is 3. Move your decimal place 1 place. And so in your answer you have to put 1 place. So the total area is 693 feet squared. Don't forget, area is always squared because you're multiplying 2 numbers together. So area is always squared. That's our area. So, in hindsight, when you have to find a scale drawing, you have to find 2 WGs. You have to do your length, then you have to do your width, your height, and then you have to multiply them together. Alright, on the back, we're looking at if they give you a scale drawing and they want you to create another one. So it says the scale drawing of a meeting hall, that just means a room where they meet, is drawn on the centimeter grid paper. The scale is 1 centimeter to 3 meters. That means that 1 centimeter is equal to 3 meters. So one of these is 3. So we have 3, 3, 3, 3, 3, 3, 3, 6, 9, 12, 15, 18 feet, or meters, by 3, 6, 12, 15, 18, 21, 24 meters. Okay, so then it says that's how long our actual, obviously this is really 1, 2, 3, 4, 5, 6 centimeters, and 1, 2, 3, 4, 5, 6, 7, 8 centimeters, but we know that each centimeter is 3 meters, so in real life it would be 18 meters by 24 meters. Okay, the question says, suppose you redraw the rectangle on the centimeter grid paper using the scale of 1 centimeter is 6 meters. Okay, so they want us to redraw it. So if I know that 1 centimeter is now going to be 6 meters, and I know I need to have 18 meters going up and down, how many centimeters am I going to need? Hopefully you said 3, because you know that 3 times 6 will give you 18. So this is 6 and 6 and 6. 6, 12, 18 meters. And then how long across though? If I need it to be 24 meters, how long across? Well, 6, 12, 18, 24. So what do you notice about what happened to the height? The height went from being 6 centimeters long to 3 centimeters, and 8 centimeters long to 4 centimeters. So the new scale, 1 centimeter, represents more or less than 1 centimeter in the old scale. Does 1 centimeter, represent more or less than 3? Hopefully you said 6 represents more than 3. And then it says the measurement of each side in the new drawing will be twice or half as long as the measurement of the original one. Well, the measurement of each side. Is the measurement of this going to be, this was only 3 centimeters, and this is 6 centimeters, so was 3 twice 6, or was 3 half of 6? Hopefully you said half. So that's just showing you how that you would redraw a scale drawing. I know it takes a lot of thinking, and it's one of those things that you have to just practice before you fully grasp the concept of it, but we're going to hopefully be doing some examples in class, and so you'll be able to grasp on really fast. I hope you all have a good night. Bye.